Have you ever flipped a coin and just had a feeling you knew how it would land? Or maybe you've held your breath, waiting for that perfect dice roll. We're surrounded by these little moments of chance all the time. But what if I told you there's a way to actually measure that chance? It's called probability, and that's exactly what we're going to break down today. Think about it. The spin of a wheel, the roll of a die, drawing a card from a deck, these are all games of chance. And they all share that same exciting moment of, not knowing. You're hoping, you're waiting, and you're really just asking one simple question. Am I going to win? And that really is the big question, isn't it? Is it all just random, pure luck? Or can we use math to figure out what should happen? Well, the answer is a huge yes. And the tool that lets us do that is called theoretical probability. All right, so to really get a grip on the theory of chance, we first need to learn its language. Don't worry, it's just a few simple core ideas. But once you get them, everything else just kind of clicks into place. First up is the word experiment. Now, in probability, this doesn't mean you need a lab coat or safety goggles. Nope. It's just any action where you can see what happens. Tossing a coin? That's an experiment. Rolling a die? Also an experiment. It's basically the doing part. And every single experiment has an outcome. That's just the word for the specific result you get. So if your experiment is flipping that coin, a possible outcome is heads. If you roll a die, one possible outcome is a 4. See? Simple as that. Now, what if you were to list out every single possible outcome of an experiment? Well, that whole collection is what we call the sample space. You can think of it as the complete picture, the entire universe of possibilities. For that coin toss, the sample space is just heads, tails. That's literally everything that could happen. So this is a really important point. We're talking about theoretical probability. This isn't about what happens when you actually sit there and flip a coin 100 times. That's a real-world trial. Theoretical probability is all about the perfect, ideal world of math. It's what we expect to happen in a perfect scenario. Okay, now that we've got the vocabulary down, it is time for the main event. I'm talking about the one simple formula that lets us calculate our chances for pretty much anything. And trust me, it's not nearly as scary as it might look. Here it is. P of E equals N of E divided by N of S. Okay, I know, it looks like alphabet soup. But what do those letters actually mean? Let's check it out. Let's break it down piece by piece. P of E is just a fancy way of saying the probability of our event. The thing we want to happen. N of E is the number of favorable outcomes, which is just a way of saying the number of ways we can win. And NS? That's the total number of possible outcomes. Hey, that's our sample space. So really, all this formula means is the number of ways to win divided by the total number of possibilities. That's it. All right, enough theory. Let's get our hands dirty and actually see this formula in action with some classic examples. I think you'll be surprised at how intuitive this whole thing is. Let's start with the absolute classic, a coin toss. We want to know the probability of getting heads. So how do we use our new formula? Well, first, let's figure out our N of S, the total number of outcomes. For a coin, there are only 2 possibilities, right? Heads or tails. Now what's our favorable outcome, our NE? We just want a heads, so that's 1. So we've got 1 divided by 2, which gives us 1/2 or a 50% chance. It's that simple. See? The math just confirms what our gut already tells us. Okay, let's level up just a little bit. You roll a standard die. What are the odds you land on the number 4? We're just going to apply the exact same formula. The sample space, all the possible things that could happen, is 6 for the 6 sides of the die. Our favorable outcome, the thing we want to happen, is just one of those sides, the number 4. So N of E is 1 and N of S is 6. And that means the probability of rolling a 4 is 1 in 6. Are you seeing the pattern here? The formula just works, every single time. Okay, last one for this round. Take a look at this spinner. It's got 10 equal sections, and they're numbered 1 all the way through 10. What do you think the probability is of it landing on any single number? Well, since there are 10 total sections, our sample space, N of S, is 10. And if we want to land on, let's say, the number 7, there's only one of those sections, so our favorable outcome, NE, is 1. That means your chance is 1 in 10, or 10%. You've learned the language, you've seen the formula in action. I think you're ready. It's time for one final challenge using something you might just have lying around the house, a deck of cards. So a standard deck has 52 cards, and those cards are broken down into 4 suits. You've got hearts,
diamonds, clubs, and spades. And believe it or not, that's all the info we're going to need for this last problem.
So here's the question for you. If you draw one card at random from a full, well-shuffled deck, what is the probability that it's a heart? Go on, take a second and think about it using our formula.
Did you get it? The answer is 1 in 4, or 25%. So how did we get that? Well, there are 52 total cards, so our NS is 52. And the number of hearts in the deck is 13, so our NE is 13. That gives us 13 over 52, which, if you simplify it, comes down to exactly 1/4. Pretty cool, right?
And that brings us right back to where we started. From coin flips to card games, probability isn't just some abstract math class idea. It's a really powerful tool for understanding the world of chance that's all around us. It tells you what should happen in a perfect world. So the only question left is, now that you know the odds, how will you play the game?